Can anyone explain to me what the photography project is? The photography project is about the development of photography, specifically the development of film on the 35mm camera. The project will go through the process of creating an image, from the time the picture is taken to its development and also how the camera works. That's very good, everyone, but please stop talking over each other. It will go over the chemicals used to create the image, along with the long history of photography. This project will cover everything that we have learned so far this year, such as polyatomic ions, balancing equations, types of reactions, and covalent bonding, and ionic bonding. Enough! Thank you all for explaining, but you all need to stop yelling. The story of photography can be traced back hundreds of years, going back as far as 2,000 years ago, when the camera obscura was invented. The camera obscura was created by Ibn al-Khithan. Obscura was a dark room that had a small hole in it where images of objects outside the dark room would be displayed on the opposite wall inside the room. However, the first production of permanent images was created by Nikifor Nicepi, a French inventor who was interested in lithography in the early 1800s. Lithography is the process of creating a picture on a flat and blank plane where moisture would repel lithographic ink and would then be pressed hard to create an image. While experimenting with lithography, Nicepi creates a new method for creating an image using lithography, calling it heliography. The method called for a person to coat a pewter plate with a light-sensitive bitumen of Judah, a naturally occurring asphalt, and expose it to light for several hours. Once the plate had been exposed to light, it would be washed and removed to get rid of unexposed parts of the picture, thus leaving an image that was etched into metal. While using the heliograph method, Nicepi created one of his most successful images, a portrait of Roman Catholic Cardinal de Ambus in 1826. This is when he displayed his image to the Royal Society in London, England in 1827. As Nicepi was getting older, he passed down his methods to Louis Jacques Médicis, where he creates the daguerreotype, a new way for a permanent image to be produced in a significantly less time than before, only taking around 3 to 15 minutes to be exposed. The process called for a person to use a sheet of copper to be plated with a thin coat of silver, then polished and exposed to iodine, light, and lastly submerged in salt. Around the same time, another man named William Henry Fox Talbot started to experiment with images. During his experimenting in 1841, he patented the calotype or taliotype, a paper negative process. This process reduced the experiment time for an image to be created and also helped in creating a faster reproduced image. The process involved a sheet of ionized writing paper by adding solutions of silver nitrate and potassium iodide to the paper surface under light. Then they would wash and dry the paper. They would then sensitize the same surface using a gallonitrate of silver solution. They would then dry the paper and load it into a camera obscura and then expose it to light. They would then remove the paper and brush it with the same sensitizing solution to develop the image to the desired amount. They would then rinse the negative with water, wash it with a solution of potassium bromide, and rinse it again before laying it out to dry. William Henry Fox Talbot would later change this fixing solution to hyposulfite of soda. In 1851, Frederick Scott Archer introduced the wet cold-down process, where a piece of glass would be situated in a dark room and would be coated with collodion and be made light-sensitive with further chemicals. Before the plate could dry, it would be placed in the camera and exposed. The plate would be placed in the dark room to be developed. The process of the glass being developed was the plate being rinsed, fixed, washed, dried, and varnished. In 1888, George Eatman marked the Kodak No. 1 box, making it easier for average citizens with no prior knowledge of taking photos being able to take them. These cameras had a roll of film inside. Once the film was used, customers would have their film developed, thus creating a personal photo. In France, the Lear brothers introduced the autochrome color process. The process of creating autochromes was made by coating a a glass plate with varnish and dusting it with a layer of translucent potato starch grains. The grains were dyed a multitude of colors and had a black carbon dust added to it. The plates were next coated with a light-sensitive gelatin silver bromide or silver iodine emulsion. When the plate was inserted into a camera, the light from the lens passed through the colored starch grains, which acted as a color filter before reaching the emulsion. After exposure, the plate was processed to make a unique, full-color, positive silver image. In 1925, the Lasai 1 became the first commercially successful 35mm camera being used by amateurs and famous photographers. In 1935, Kodak introduced Kodachrome, the first color transparency film and the first successful mass-marketed color film, being available in 8, 16, and 35mm film. In 1947, Edwin Land introduced the first instant camera, the Polaroid Land Camera Model 95, which produced prints in approximately 60 seconds. The camera gained mass popularity because of its ability to produce a photo in almost instantly. In 1975, Steven Sasson, an engineer at Kodak, develops the first digital camera, opening the door for a new medium of creating photography, one that does not involve the need for film and does not require as much time to produce. Images were recorded on a memory card, where when a photo was taken, the light coming in through the lens of the camera would strike an image sensor. The signal output by the image sensor would then be produced within the camera to create an image data that would then be stored on the memory card. By the 2000s, digital cameras outpaced film cameras and became the new dominant photography medium for people to take photos. By the time companies such as Kodak started to go under because of the lack of demand for film cameras. By the 2010s, cameras are now available on portable cellular phones, allowing for photos to be taken anywhere at any time. This also allowed for cameras on phones to have much larger storage than their other counterparts. During this time, social media starts to be a large part of the world's culture, and photos become the epicenter of major social media platforms such as Instagram, Snapchat, and Facebook.
Hi everyone, I will be discussing how the 35mm camera works.
For starters, the 35mm camera is first loaded up with a roll of film, usually containing between 28 to 36 possible photos. The film that is used is a plastic-coated film that has a gelatin emulsion mixture containing light-sensitive silver hide crystals, the gelatin acting as protective layer, and the silver hide crystals acting as what is going to be exposed to create the image. There are several components that make up the 35mm camera. First is the lens. The lens is a sheet of glass and plastic at the front of the camera that also allows light to be directed inside of it. Next comes the aperture. The aperture is a small opening in the lens whose size can be adjusted to manage how much light a person wants to come into the camera. The shutter is a structure of the camera that contains a series of flasks that open and close at a fraction of a second to allow sets of light into the camera to expose the film. The shutter speed can affect the overall photo. The faster the shutter speed, the crisper the image. The film compartment is where the film in the camera is set to be prepared for the image to be taken. The film is laid flat at the end of the camera directly across from the shutter. The viewfinder is a small area of the camera where a person can see the image that they are going to take. The image can be seen via a mirror that light bounces off from and hits a prism that directs the light toward the viewfinder. When a photo is taken, the light that bounces off the person or object that you are taking enters the lens of the camera. The light then passes through the aperture, which then allows the light to further enter the body of the camera. The light then bounces off the mirror inside the camera and reflects off the prism and points the image to the viewfinder compartment. Once a person clicks the shutter down after seeing the desired image, the mirror then raises and the shutter opens, allowing light to pass through the lens and aperture and hit the film at the back of the camera. This creates an image on the film upside down to what the person is taking a photo was seeing through the viewfinder. The film is then moved due to a motor, which then adds a new section of film waiting to be exposed. to develop the 35mm film and what types of chemical reactions and chemistry is used to create the photos that we took with our cameras. Before developing the photos, our group first needed to take photos on our 35mm camera, taking a total of 36 photos. The day before the lab, we first prepared the film by adding it into a black bag with a plastic container. We first took the film out of the camera and took off the container lid and took out the reel inside of it. We then winded the film around the reel whilst it was inside the black bag. Once the film was completely on the reel, we put it back into the black container and then closed it. We then took out the black container from the bag, and this was our starting point for the lab. On the second day, our group got the necessary materials to develop the film. Our group got 4 solutions: water, Kodak D76 stock developer, Kodak stop bath, and Kodak Professional Rapid Fixer. We then got 4 different 600 to 800 milliliter beakers, 2 thermometers, 2 aluminum pans, and a timer. After getting these materials, we added hot water to one of the aluminum pans and ice water to the other. We next added our 4 solutions into each individual beaker and then labeled it. We then put our water developer and stop bath beakers into the cold and hot water in the aluminum pans and tried to make them both 21 degrees Celsius, switching them and stirring them for each water pan depending on their temperature. Once this was going on, one person from the group would be designated as a timekeeper, one as an agitator and the other as an everything person. After the members of the group were labeled, the everything person made sure that the solutions were at the correct temperatures. The timekeeper would keep track of time and the agitator would handle the solutions and chemicals and help develop the film. The first thing that the agitator did to develop the film was to pre-soak the film, which involved them taking off the red top of the container and adding 21 degrees Celsius water into the top of the container very quickly. Once the water reached the top of the container, the lid was quickly closed. This is when the timekeeper set a timer for 1 minute. Once this minute was up, the water was then dumped into the sink and the developer was then added to the container. After the developer was added, the agitator starts to agitate the container gently and the timekeeper makes sure the developer is agitated for 30 seconds at a time with 5 seconds rest in between, doing this for a total of 9.5 minutes. After the 9.5 minutes were up, the developer was dumped into the sink and the stop bath was immediately added to the container. The agitator then agitated the container for 30 seconds and had 30 seconds rest. 5 second agitate, 30 second rest, and 5 second agitate, 20 second rest, doing this for a total of 2 minutes. After this, the stop bath was dumped into the sink and the fixer was then added. Once the fixer was added to the container, the lid was then closed and the agitator agitated the container for 30 seconds and rested the container for a minute and then agitated for 5 seconds and rested it for 30 seconds. The agitator did this for 7 minutes while the timekeeper kept time. After the 7 minutes were up, the fixer was dumped back into its beaker and then dumped back into the container. This is when the black container was filled with water to the top and dumped, this process being done 10 consecutive times. After this washing and dunking period was done, the container was then filled with a new solution called permawash, which was added to a new 600 to 800 milliliter beaker. Once the container was filled, the permawash, the agitator agitated the container for a minute. After this minute was up, the permawash was dumped into the sink and 30 consecutive wash and dunks occurred. When the 30 wash and dunks were complete, another new solution called PhotoFlow was added to the beaker and then added to the container. When the PhotoFlow was finished being added to the container, it was then agitated for 30 seconds. After 30-second agitation was done, Ms. Smith opened the container and took out the film with tongs and used a curling iron pressed down on the film. Once she did this, we hung up the film on a clothesline for a day. After we had done this, we immediately cleaned up our station and washed the container and reel with soap and water and let it set to dry. Once this was completed, we completed our lab. When the film was done drying, we observed the film was fully independable. We then put our developed film under a light box to see which photos were perfect, undeveloped, or overdeveloped. Our group counted that we had a total of 12 perfect images, 17 underdeveloped, and 7 overdeveloped. We noticed that the perfect images had a clear, crisp image, underdeveloped film was dark in color and was hard to make out an image, and the overdeveloped film was white/gray and was also hard to see out an image. Our group also looked at another group's film, and we noticed that their entire 36 film roll was underdeveloped. From developing the photos, I have learned more about developing photos and the chemistry behind them. From this lab, I have found out that the speed and force of an agitation of chemicals drastically affects the final product. I also found out that performing certain actions at certain times and temperatures is necessary for labs to be done correctly. From this lab, I also found out about the complex chemistry that is involved in creating a photo. From conducting this experiment, I observed that when the film was done drying, we observed the film was fully independable. We then put our developed film under a light box to see which photos were perfect, undeveloped, or overdeveloped. Our group counted that we had a total of 12 perfect images, 17 underdeveloped, and 7 overdeveloped. We noticed that the perfect images had a clear, crisp image, underdeveloped film was dark in color and was hard to make out an image, and the overdeveloped film was white/gray and was also hard to see out an image. Our group also looked at another group's film, and we noticed that their entire 36 film roll was underdeveloped. In our lab, there were several reactions that occurred. The first being when the silver bromide that was in the film was exposed to light, which can be seen in this equation. When the silver in this reaction is exposed to light, it is exposed to more energy and thus creates the latent image on the film. The exposed silver bromide becomes the latent image, and any unexposed silver bromide becomes the shadows of the image. When the film interacted with the developer traded an electron to the silver ion to make it a silver metal. For this reaction to occur, oxidation must occur, which would give the electron to the silver. In this reaction, the developer interacts with the film to get silver hydroxide and bromide, which help to develop the image. This reaction is a double replacement reaction. To stop the developer from developing any other silver bromide, the stop path is introduced, which is an acid. The stop path counteracts the developer because the developer is a base, and when it interacts with an acid, an acid-base neutralization reaction will occur, which would stop the developer from developing any further. The fixer's role is to make the film insensitive to light. Permawash helps to protect the image, in this case, film plus ammonium sulfate. From conducting this lab, our group committed several mistakes. One being that I was being inconsistent with how fast and quick my agitation was, and also how quickly I was putting the different solutions into the container. The other being that the timer for our timekeeper reset, so we didn't have the most accurate time for when we were agitating and resting the solutions in the container. This might have caused the developer and the other solutions not to have enough time to develop all the images. For these reasons, our group only got 12 perfect photos. In another group that we observed, we noticed that they had no perfect pictures, all of them being underdeveloped. This is because the timekeeper did not keep track of time accurately, causing the photos to not be developed correctly. My group was able to meet the objectives of the lab because we were able to develop the photos that we took on the 35mm camera. I was also able to understand the chemical reactions that caused the photos to develop and the chemistry behind
how all the solutions interacted. From conducting this lab, I have learned more about chemical reactions and how each unit of chemistry that we have learned in class all interact to create photos. From this lab, I will have a deeper understanding of chemistry in my day-to-day life and will be able to know how exactly how photos I take on film camera are developed.